Hello students, this is the video for 3.6 roots practice on Tuesday of our asynchronous week. Today I just want us to focus on actually identifying roots from the function, and tomorrow we'll get back to our factoring topic. So remember that this is the factored form of our quadratic function. All of these are quadratic functions that have been factored. They've been taken from standard form to factored form. And again, tomorrow we will look again, like what we looked at the end of yesterday's video and yesterday's practice, going from standard form to factored form ourselves. But today, let's just really make sure that we know, once we have our factored form, what our roots are. Remember again that roots on our graph are where our curve crosses or touches the x-axis, and so they actually mean something when we get these. And so when we have our factored form, we can get our roots by thinking about the possibilities of what x could be to make this equation true. So the reason that we set this equal to 0, and I didn't talk about this yesterday, is that when you have a root, roots always have an x value and then a 0 as their y value. And so normally we say our functions are y equals or f of x equals. To solve for what x equals at these places where it crosses the x-axis, we have our x and our y-axis. These places are going to have, they're not going to move any place in the y direction. They're going to cross the x-axis at an x value. They're going to have no movement up or down. And so that's why we set it equal to 0. And then we're able to ask ourselves, okay, what x values for this quadratic function make this true, and therefore those are the x values where that specific graph goes through the x-axis. So let's look at these. For example number 1, we have x plus 3 times x plus 7 equals 0. So again, factored form is having two things being multiplied by each other. Factors, like we know factors of, what are factors of 4? Those are things that multiply together to get 4. So same thing. Now we just have unknown numbers or variables there. So x plus 3 times x plus 7, we have these two pieces that are being multiplied together to get 0. The only way that you multiply two things and you get 0 is for one of them to be equal to 0. So we want to say, okay, what if x plus 3 is equal to 0? And then what if x plus 7 is equal to 0? So if x plus 3 is equal to 0, what will that equal? And then if x plus 7 is equal to 0, what does that make x equal? So now we have two pretty simple linear equations to solve. In this case, you can just think, okay, what number plus 3 equals 0? Or you can subtract 3 from both sides. Either way, we get x equals -3. Same thing here. We can say, okay, what number plus 7 equals 0? Or we can subtract 7 from both sides, and 0 minus 7 would get us -7. So our roots are x equals -3 and x equals -7. If we were to actually go graph this quadratic function, even though it's in factored form, you can go type it into Desmos just like you see it here. Our graph would cross the x-axis at -3 and at -7. So let's look at another example. That was a time where we had two factors, both plus. We ended up with two negative factors. Example number 2, we ended up with two negative roots rather. Example number 2, x minus 2 times x minus 5 equals 0. again, either this piece equals 0 or this piece has to equal 0. So let's look at our green piece. X minus 2 equals 0. What will x equal if x minus 2 equals 0? What minus 2 equals 0? That's going to be positive 2. Then, if x minus 5 is the one that equals 0. It doesn't have to be both, it just has to be one or the other, but we want to know what that will be. So what minus 5 equals 0? That's going to be x equals 5. Okay? So notice two positive addition factors, we ended up with two negative roots. Two subtracting factors, we ended up with two positive roots. All right, let's look at another one. Example number 3, we have x times x plus 8 equals 0. Even though this is just a plain old x here, it's still something that is being multiplied, and so it could be equal to 0. So either we have x equals 0, or we have x plus 8 equals 0. Subtract 8 from both sides, or just think about what plus 8 equals 0. That's of course going to be negative 8. There's nothing that we have to do to solve for this because it's already x equals 0. So those are our two roots. Example number 4, we have x minus 9 times x plus 4 equals 0. Now, at this point, you may just be able to say, all right, x equals 9, x equals negative 4. If you can go ahead and jump there without having to write out your equations, that's totally fine. That's a great thing because you can solve these quicker. But we can also still think about, okay, this piece being equal to 0, this piece being equal to 0, and then solving those two equations. If this helps you break it down and get the right answer, do that every time. So we would add 9 to both sides. Since we're subtracting, we'd end up with x equals 9. Over here, x plus 4 equals 0. We want to get this 4 to the other side. We'd subtract it, so we end up with x equals negative 4. Finally, example number 5, x plus 1 times x minus 6 equals 0. We'll say x plus 1 equals 0. Or x minus 6 equals 0. X plus 1 equals 0 would give us x equals negative 1. X minus 6 equals 0 is x equals 6. Again, I want to point out, notice how when you have the piece, the factor that's being multiplied, your root ends up being the opposite sign, because a number plus its negative is always going to be 0. So when we have positive 1, we end up with a root of negative 1. We have negative 6 or subtracting 6, we end up with a positive 6, which makes sense for how we solve it. All right, so that concludes today. And our practice today is only going to be on identifying these roots. Okay, so breaking it down a little bit, slowing it down a little bit. Tomorrow, we will get back to practicing getting factored form.